Okay, so we're talking about moments on a supported beam, and here's our question. A plank of weight 70 newtons and length 5 meters rests on supports at points C and D. The distance from A to C is 0.4 meters. The reaction on the rod at C is 9 newtons. We're going to calculate the reaction force, Y, and the distance between C and D. Seems hard, but there's a really easy way to do this. We're going to break it into two very small bits. The first bit is we know that the forces are balanced, so the forces up must be the same as the forces down. If that wasn't true, the plank would be moving. So we can say the forces up, which are 9 and Y, if we add those together, they must equal the forces down, which would be the weight of the plank. Now look where I put the weight. The weight would act at the center of gravity, so I'm going to put it right in the middle of the plank there. If this is true, then Y is easily, we can work that out, 61 newtons. The second part is a little bit harder, so we're going to use the principle of moments to work it out. So for B, we're going to remember the principle of moments. But first, we're going to draw on everything we know. We know the 70 newtons is in the middle, so it's 2.5 meters from either side. We're going to pick a pivot. In this case, we're going to choose pivot C. Doesn't matter which one you choose, but I've chosen C. So the principle of moments is the clockwise equals the anti-clockwise moments. So the clockwise, what does that mean? Well, if we chose C, if we chose this 70 newtons, it would go clockwise around C. So 70 newtons times, now this is 2.5 minus 0.4 away from C. So that's a 2.5 here, minus A to C was 0.4. So I'm going to take those two away from each other, and that's the distance to C. And then on the other side, anti-clockwise, Y would go anti-clockwise around C. So this is going to be Y times the distance between those two pivots. In this case, 70 times 2.5 minus 0.4 is 147 newton meters. Now you can work that out. That's very easy to work out. It's just 70 newtons times 2.1 meters. Notice the units I've got here, newton meters. Then I divide that by Y to move it down, so I've just got the length of CD here. Now this is, you should do this, you should use the units, because once I get rid of those newtons, newtons divided by newtons is nothing, it leaves me with meters, which is telling me that I'm working out the right thing, I'm looking at this distance. So 147 newton meters divided by 61 newtons is 2.4 meters. So the distance from C to D is 2.4 meters. Very easy to do, just those two things to work it out.